next thing I want to talk about is friction. Obviously, the greater the friction value here, the greater the shear load you can carry. So there's a number of typical friction values that you can have a look at. Obviously, you might want to tailor your joint to increase the friction. That would be a sensible idea. Now we're going to come on to applying actual loads to our joints and see what really happens. So I've got two cases that I'm interested in, and generally we'll be interested in two cases. We might have lots of forces acting on this joint, but we'll probably be interested in the maximum tension force, and that's as one case, and the maximum shear force as another case. So let's take the maximum tension case first, and I'm going to apply a tension load of 65 kilonewtons, and I'm going to apply a shear load of 2000 newtons. Now, because we've got a coefficient of friction of 0.2, to carry 2000 newtons I need a clamp load of 10,000 newtons. So that's the required clamp force that I need to carry my 2000 newton shear force. So I'm going to pop on this first case now. I'm going to draw it onto the diagram, and we can see what happens here. We've got this is the external load, 65 kilonewtons, corresponding to this value here, and we can read off that, well, the maximum tension that we'll see in the bolt, if we were doing a detailed stress analysis of the bolt itself, the worst case for the bolt, the maximum tension case, would be in fact this point here. It wouldn't be this point here because we start with a minimum pretension, we increase from there, so it would be in fact that. But what's interesting when we think about contact forces, when we come to determine what's the minimum clamp force we have, there's obviously no point in using the maximum pretension case, because that gives you a higher clamping force than the minimum pretension case, which gives me this load here. It says that the available clamping force is 34.5 kilonewtons or so, and I require 10,000. So you can see that provided this point is below this point here, then we'll be fine for carrying our shear load. I'm now going to show you this next case, which is the maximum shear case. So we've actually got a higher value of shear, a lower value of tension, and let's just plot that on the curve. Okay, what we can see here, this time we're only applying 25,000 newtons, and our minimum clamping load is then 65 kilonewtons, and we want to apply an 11,000 newton shear force, which when we use the coefficient of friction means we require 55,000 clamping force. So this value is actually getting very close to the available clamping force, and that's demonstrated in the demand to capacity ratio being quite high here. It's well, as soon as it gets above 1, then we have a problem. So let's generate a few problems. Let's go to the next size of bolt down. Let's choose an M20 this time. Okay. Now we've got the same applied loads, and one thing we can see here is this has now gone red, and it's telling us that we have a problem because we can't carry the shear force, and it's shown diagrammatically because the required shear force the required clamping force of 55 kilonewtons is now above the available clamping force of 48. So we run the risk of this joint slipping, and you never really want to allow any joint to slip, because as soon as you start moving, they're in the danger of becoming loose in service, and all kinds of problems will follow that. We could take the calculation to an extreme. We could choose an M16 bolt, and this becomes particularly silly, and it's actually, there's a few things going wrong at the moment here. One thing that it's throwing up is that we have a 65 kilonewton load applied, and our separation load, the load at the point at which the joint separates, is this value here, which you can actually read off at the bottom, which is 57 That's that value there. So that's and when the joint separates, then it clearly can carry no load. So I wouldn't be very happy with this this diagram at all. Really, what we have to do is go the other way and go for a bigger bolt, and we can see here that the joint is far more capable of carrying the maximum tensile load and the maximum shear loads. So I hope this has given you some idea of why we need to think about bolts. I hope it's made sense to you. We need to think very carefully about these factors here, the thread factor, the friction, and the amount of pretension we'll get for the available tightening torque. This value here, which is the stiffness factor, which decides how much load that we apply to the joint actually goes into our bolts. This factor here, which is the tightening factor, which determines our spread of pretension values. And finally, our friction force. All these terms are important when it comes to bolt design. Thanks very much for listening.